Hello everyone, how is it going? My name is Ahmed Inaya, and in this video I will discuss the conversion between decimal, binary, and hexadecimal numbers. In part 1 of this video, we discussed these systems, and in this part I will discuss the conversion between these systems. In this video I will discuss different types of conversion. I'll start by talking about binary and hexadecimal conversion, which is a direct conversion because these two systems are compatible with each other. I will discuss binary or hexadecimal to decimal, and this conversion needs multiplication and addition. I'll discuss decimal to binary or hexadecimal, and this needs division and remainder method. At the end, I'll discuss a way to convert from decimal to binary without any division or multiplication by using simple comparison and subtraction. Let's start by talking about the conversion between binary and hexadecimal. These two systems are compatible with each other. 1-digit hexadecimal is converted into 4 digits binary and vice versa, which means 4 digits binary are converted into 1-digit hexadecimal. We can use this conversion table, which can be generated easily by converting decimal to hexadecimal to binary. So let's take an example. This is a binary number which is 8 digits, and we want to convert this number into hexadecimal. So the conversion is direct. We take the first 4 digits, 0111. We know that 0111 is 7 decimal and 7 hexadecimal, so the first digit is 7. Then we take 0011. We know this number is 3 hexadecimal and 3 decimal. So 0111 0011 binary is 73 hexadecimal by using this table that can be easily generated and easily memorized by most network engineers. Let's take another example for hexadecimal number. We have this number 5F and we want to convert it into binary. So by using the same formula, number 5 is 0101 and number F hexadecimal is 1111 binary. So you can easily do this conversion by using this table and memorize it, and you can easily convert any binary to hexadecimal and vice versa. Let's move to another type of conversion, which is binary or hexadecimal to decimal. This conversion is easy also, and we discussed it in part 1. It all depends on multiplying each digit with its decimal value, and then we add all these values to get the total in decimal. So let's take an example. This number binary 01001100, and we want to convert this number into decimal. So let's do the math. We have this number here in binary, and we know the value of each digit. We know that digit 0 is 1, digit 1 is 2, digit 2 is 4, and up to 128 for digit 7. We put each digit under the value of that digit, and then we do the multiplication. We multiply each digit by the value of that digit in decimal. We have these values here, and to convert this number into decimal, we do the addition of these numbers to get the total of 76 decimal. So this number binary equals 76 decimal. Let's apply the same concept for hexadecimal. We have this number E8 hexadecimal, and we want to convert it into decimal. We do the same math. We know the value of this digit is 1 and the value of this digit is 16. We do the multiplication. We multiply 16 by 14. E is equivalent to 14 in decimal. So we multiply 16 by 14 and we multiply 1 by 8. And we do the addition to get the equivalent number in decimal, which is 332. So E8 hexadecimal equals 332 decimal. Now let's try decimal to binary or hexadecimal. For decimal to binary, we divide by 2 and we repeat this division until the result of division is 0. The remainder of this division, whether being 0 or 1, of the first operation is digit 0, then 1, and so on. The same applies to decimal to hexadecimal. We divide by 16 until the result of this division is 0, and we convert remainders into hexadecimal here because the remainders can be above 10. So we convert them into hexadecimal. The remainder of first operation is digit 0, then 1, and so on. So let's start by an example for decimal to binary conversion. Let's take this number 239 decimal and we want to convert it into binary. We start by dividing 239 by 2, and this is 119, and the remainder is 1. We take this 119 and we divide it again by 2. The result is 59, and the remainder is 1. So this one is digit 1. Then we take 59, we divide it by 2 again, the result is 29, and the remainder is 1. We divide 29 by 2 again, the result is 4, and remainder is 1. We divide 14 again by 2, the result is 7, and then we divide by 2 again, the result is 3. We divide by 2 again, the result is 1, and now when we do the division, the result is 0, and the remainder is 1. Once we reach 0, this is the end of this operation. Now we take these digits and we map them into digits 0, 1, 2, 3, 4, 5, 6, and 7. And this way we get the equivalent. So 239 decimal equals 11101111 binary. Now let's take an example for decimal to hexadecimal. We have this number decimal 234 and we want to convert it into hexadecimal. We do the same way. We divide this number by 16, the result is 14, and the remainder is 10. 10 is the decimal number. We want to convert it to hexadecimal before sending it to digit 0. So this is A. Now we divide 14 by 16, and this is 0 with a remainder of 14. 14 decimal equals E hexadecimal, and this is digit 1. Now as we reach 0, this is the end of this operation. So now we take these numbers, which are A and E, and map them into digit 0 and digit 1 in hexadecimal. So 234 decimal equals EA hexadecimal. Now if you are not a fan of multiplication and division and you prefer to do subtraction only, there is a shortcut that may make this simpler for you. So it is common to convert numbers from 0 to 255 from decimal into 8 digits or bits binary, and this is what we need in networks most of the time. So we can use simple way that depends on comparison and subtraction, as I will show in the coming example. So for example, we have this number 215 decimal and we want to convert it into binary. And we want to convert it into binary without multiplication or division. And we want to convert it into binary without division or multiplication, only by depending on comparison and subtraction. So let's expand this number. First of all, we know the value of these digits. Digit 0 is 1, digit 7 is 128. We start by the first digit. So 215 is larger than 128. So we put 1 here and we subtract 215 minus 128. So we still have 87. We move to the next digit. 87 is larger than 64. So we put 1 here and we subtract 64 from 87. The result is 23. 23 is smaller than 32, so we have 0 here, and we keep 23. 23 is larger than 16, so we have 1 here, and we subtract 16 from 23 to get 7. 7 is smaller than 8, so it is 0 here. 7 is larger than 4, we do 1 here, and we subtract to get 3. We apply the same concept here. 3 minus 2 is 1, and we have 1 here. So this way we converted 215 into this binary number by using only subtraction and by comparing the value of this number with the value of these digits in binary. So this number 215 decimal equals 1101011 binary. With time, you might be able to create your own shortcuts to convert decimal to binary. And if you have any shortcut that you like more than this one, please let me know in the comments. If you find this video useful, please like, subscribe and share, and let me know in the comment if you have any other subject you would like to discuss in this series. Thank you and have a good day.